Hi everyone, in this video we're going to finally get into some information about triangles. So a lot of this I hope is review. I might be sneaking in a few new things, but again, just let me know if you are trying to work through this homework and practice any of these and they seem really tricky or you don't quite understand. Okay, so first one I'm going to do a lot of labeling. I'm going to say this is angle A and this is angle B. And this is angle C. And I'm also going to drop a perpendicular. So this is going to be perpendicular to the base of the triangle. And then I'm going to label some lengths. So those were angles that I was labeling. And then I'm going to say across from angle big B is side little b. This is really common labeling that you'll see, and we'll use it a lot just to make life easier. So pairing angle A with side A, across from it, angle B with side B across from it, and angle C with side C across from it. C is not always ideal. Let's make that look bigger. Is a common practice. The other thing that you'll see is angle alpha with side A, angle beta with side B, and angle gamma with side C. Okay, so, oh, one more thing. I want to label that the height of the triangle, the height of that perpendicular is H. Okay, so things I think we should know, a couple of things that hopefully we've hit in an algebra or geometry class is area of a triangle. I think it's probably even come up for us in this class, although I don't remember for sure. Area of a triangle is 1/2 base times height. So basically, if you fit this thing in a rectangle, the triangle takes up exactly half the area of the rectangle. Oh, sorry for the wiggle. We can also talk about perimeter. Oh, let's say the word area there so that we don't confuse you. Not angle A, area. Perimeter. Perimeter, there's nothing special about perimeter of a triangle. It's just A plus B plus C. So no nice things like rectangles where you have some sides of the same length or squares. Just add the three sides up. And then last one, this one is not one that I see so often in algebra, but if you've had any geometry, it's probably come up. The sum of the angles has to be 180 degrees. So any triangle, it doesn't have to be a right triangle, it doesn't have to be any sort of special kind of triangle. Any triangle, the internal angles should sum to 180 degrees. Okay, so again, I'm not going to go through tons of examples. I'm just going to present some information. I will go through a few examples at the end, but I just want to give you guys one day or one packet to sit and think about some of this triangle stuff and make sure that you're comfortable with it. So those are things that I would expect you to know. And this one we'll use a lot. You may have not had to you may not have had to use that a lot before, so much struggle, but you will a ton when we're working with triangles. Okay, so there's a couple of specific triangles that we're going to talk about, and then one that we're saving for later. Right triangle is also a specific type, and it's very important to us, and we will catch that next. So first, I want to talk about this. So let's say we have two side lengths that are the same. So I'll call this S, S, and this is some other side length. This is called an isosceles triangle. Let's see if I remember how to spell it. Isosceles. I think that looks right. Okay, so isosceles triangles have pairs of sides that are the same length. And we can also make some claims about their angles. If the two sides here are the same length, the angles opposite are also going to be the same length. The one across from X probably won't be, but the two angles opposite the sides that are equal will also be equal. Okay, and then what's going on in this one is we're supposed to have all three side lengths the same. So let's just call this, I don't know, let's use a letter we haven't used. W, W, W. Okay, so all three sides the same. This is called equilateral. I'll try not to get too vocab heavy on you, but those two definitely come up. I think it's worth remembering those two. They'll come up in calc classes as well. And once again, we can say something about the angles. If all three sides are the same length, then all three angles will be the same, which actually allows us to go even further. If all three angles are the same, so let's just call these thetas, Then 3 theta, we just said the three angles have to add up to 180 degrees, which means theta is 60 degrees. So if you have an equilateral triangle, you know that the angles are all 60 degrees. That's a freebie. Okay, and then similar triangles. This is a really big one. So similar triangles, in theory, I hope it's kind of easy, but I find that people have a little bit of trouble. Okay, so the idea is that two triangles are similar if they have the exact same angles. So here, the top angles would be the same. In the bottom corner, this big wide open obtuse angle should be the same. And then this last one should also be the same. So all three angles are the same, which means that the proportions of the triangle are exactly the same. This is just a scaled up or scaled down version. These two are scaled up or scaled down version of each other. All angles are the same. So that's the key thing with those. Okay, so what happens is just what we said. The two triangles are proportional. So if we take the ratio of any two sides on one of the triangle, it should match up with the corresponding ratio on the other triangle. So I'm going to go ahead and quit trying to come up with new letters and just say this is A, B, C. And over here we can do D, E, F. No little e's because that represents a number in math, but we can use a big E. Okay, so we should be able to pick any ratio. So for example, if I want to start with the ratio of A to B on the little triangle, it should be exactly equal to the ratio of D to E. If we've scaled this triangle up, then we've multiplied all three sides by the same number, which means when we divide sides by each other, it'll cancel out that scale factor, and the two should be exactly equal. We could also pick the ratio of A to C, which should equal D to F on the big triangle, or B to C, which should equal E to F on the big triangle. Getting off the page a little, sorry, E to F. And the reciprocals of these should also hold. So if A to B is the same as D to E, then B to A should be the same as E to D. So B to A should match up with E to D. And C to A should match up with F to D. So C to A goes with F to D. And C to B goes with F to E. So there's C to B and F to E. So there are 6 ratios, and then you can actually scramble this so you do things like the ratio of A to D is equal to the ratio of C to F. And that is actually true, but that's just a variation of one of the ones that we already have down here. So if you've got these 6, you can do anything you need to do. In fact, I would say if you've got the first 3, you can do anything because you could always just rearrange to get the last 3. Okay, last one, and it's the big one. Let's look at right triangles, properties of right triangles. Okay, so not that there's such a huge list, but just we're going to spend a lot of time working with this. If we are looking at a right triangle, you should have a right angle labeled for you. If it's not labeled, don't assume it's right. If you think I've forgotten to label it, ask me. I will tell you. I will try very hard not to forget though. Okay, I'm going to label sides A, B, C. The big thing that we have and actually have been using all quarter is that if you're working on a right triangle, it should follow the Pythagorean theorem. The sum of the squares of the two legs should equal the square of the hypotenuse. So a squared plus b squared should equal c squared. It is really important that c is the hypotenuse. Hypotenuse, there we go. Okay. Otherwise, A and B are interchangeable. It doesn't matter, but the one that's over there by itself has to be the hypotenuse. Using this, we can actually quickly generalize. So, for example, if I wanted to say I was given A and B and I wanted to find C, I would just add up A squared plus B squared and take the square root, not divide. So this is kind of a given, and you can just continue plugging A and B into the quadratic formula or into the Pythagorean theorem and solving. But I would just say we're going to use this a ton. We've already used it a ton. I hope we're really comfortable with the whole process. And if you can just mentally see that you're going to add up A squared and B squared and take the square root, do it. I don't need to see work for that. And then if we wanted to find one of the legs, so let's just say we wanted to find A, we would have to rearrange a little bit more. We'd have to subtract b squared. So we would say a is going to equal c squared minus b squared, and then we would take the square root. So feel free to jump straight to using one of those formulas. I don't need to see you start from this arrangement every single time. Okay, so those are the things you're supposed to remember about triangles. Let me know if you need clarification on any of those. And I have one more video and I'll do a few examples in that one. Thanks for watching.